if you have some smartphone base type, you certainly cannot call the play iTunes list feature on that. That's exactly the same reason. And also you follow this example quite easily. And also if you're trying to reassign something that's more general to something that's more specific, this will not be good either. Because let's say, if you are trying to say, I am expecting some iPhone, can you actually just give me some smartphone? Can you actually do that? Let's say you can. Let's say, if you can, that means I can now say iPhone dot play iTunes list. You can see that the problem for this is, now although it's called iPhone, but it's actually a smartphone. And smartphone actually has no feature that's called play item list defined. So you simply cannot do that. Okay, that's why this will be disallowed. This is also something you learn from the Java course. You can only assign something that's more specialized to something else, but not the other way around. Okay. Okay, let's continue with this. Okay, and then finally, exactly what I said. So depending on what objects you actually attach to P. So when you say P, the parameter, you actually depend on which attachment it is currently. Okay, that's exactly what I just said before the break. Okay, polymorphism. So I think these are simply actually the slides have many repetitions, so it's good for you to keep confirming your understanding. So I think I've said it all already. Let me see. Okay, so basically just specific to this particular example here. Okay, so now the typing problem here, so this is actually a little bit more, it's a little bit dry, a little bit theoretical. So this tells you a little bit theory about how the iPhone compiler works. Like how iPhone compiler determines if your code should be compilable. So for example, normally in iPhone you may have a feature call. So for example, you say iPhone play iTunes list. So should this particular line of code be compilable? So how does iPhone figure out? So as I said before the break, what iPhone compiler would do is to look at what's the static type for this particular iPhone variable. And to actually see if this feature here is actually defined in that base class. If it is, then this should compile. Otherwise, you will not compile. Okay, it's that easy. Okay, so these are just like a text definitions for that. So, okay, so type violation, this is where you actually might have some violation of the types. So please just read it through. So these are just the normal type checking process for iPhone. Okay, so now once we know what the typing problem is, so what we want to do is to say, we want to statically check to see if the iPhone compiler will work. Maybe one of you actually program in Python in the class. There's a programming language called Python. So that one, the typing system is sort of the opposite to iPhone. It's actually a very popular language for programming web systems. So basically, in iPhone, it's called statically typed, but in Python, it's called dynamically typed. The difference is, in iPhone, let's say if you're trying to, there are many errors iPhone compiler will be able to tell you before you ever start executing your code. However, in a dynamically typed language like Python, actually I'm quite surprised, maybe not many of you actually heard about that. Okay. It's actually a language for web programming. So I guess maybe many of you later on, if you find a job as web programmer, I'm pretty sure you actually get exposed to Python. Anyway, so the crucial detail to note is that it is dynamically typed. For example, let me give you, let's say, in iPhone, if you say withdraw, let's say this is a feature call. So some count, withdraw, and then let's say 23, for example. So let's say in the case of iPhone, there are two things in this case you will check. First of all, to check to see if the withdraw feature is defined in the base class of ACC variable. In this case, the base class for act is actually simply account. The account class does have the withdraw feature defined. So this part of check was okay. Okay, so first, withdraw is defined in the base class of ACC, which is account, okay? And the second check to do is to say the expression of 23 is an integer. Okay? So these are things that Alpha compiler will be able to check for you before you ever run your code. Okay? That means if you say ACC dot withdraw, let's say if you simply put true here, so true is a Boolean value, it's not really a real number, right? And so in this case, Alpha compiler will tell you that no, you better fix this before you start executing your code. Or if you're trying to say ACC dot, let's say move left. Okay, Alpha compiler will also tell you no, this is not good because you don't have the move left feature defined in your account class. Okay, but now in a language that is dynamically typed, you only learn about such errors at the runtime when your program crashes. Okay, if you actually put the same 2 lines of code in a language like Python, okay, like that's dynamically typed. Like dynamically typed, so this dynamic is really the key word. So these 2 lines will be considered as compilable. And you will only learn about the errors about, for example, the move left is not really defined in the class, and also true is not really like an integer, only when you actually run into some runtime exception. Okay, that's the difference between static type and dynamic type. Just to broaden your knowledge, basically. So for iPhone, everything is done for you statically, which means before you execute a program, you do have some certain assurance about the safety of your program. Okay, so this is completely dry, but it's just there for your information there. So just about how you can figure out the type checking for iPhone. Okay, for type checking here, so you actually want to do typing and binding. So typically, we really want to check the typing statically and binding dynamically, but why? Okay, we are going to give you some example as to why. Okay, so you're going to link this to polymorphism and also redefinition for your features. So for example, when we say we do static typing, so let me just go back to our form example here. Okay, so now we have, let's say, again, we have P1, so we have smartphone. And then we also have P2, iPhone. So when you say P1 is assigned to be P2, and then you would say P1 dot check email. Okay, let's say you might have some other code that actually happen in between the lines. Okay, so now this line of code is actually checked for validity statically, which means P1 has the static type of smartphone, and P2 has the static type of iPhone or base types. So now you're trying to assign something that's more specific to something that's more general, that is considered as valid according to the type rule in the previous slides. So this is done, the check is done statically for you. But now, when you actually reach this line, you're trying to call the check email feature, which is defined at this top level here. But the check email feature, you actually have different types of implementation in the subclasses. You might have the version in the iPhone, you might have the version in the Samsung. You don't actually know which version it is until you actually reach the line of code. And as I said before, to actually figure out what exactly this P1 is attached to is actually an undecidable problem. It's actually like a theoretical limitation. Given a fragment of code, you simply cannot figure out what exactly it is going to do. So that is why we really want to do, when we want to decide which version of the check email should be invoked, either from the iPhone or from Samsung, we really have to run the code to see. That's something the iPhone runtime monitor will do for you. Okay? So very important for you to know, this is done statically, and this is done dynamically. Okay? So this is checking to see if the assignment, the polymorphic assignment, is valid, and this is to make sure you choose the version that corresponds to the current shape of the variable. Okay? Please make sure you really get those two lines clear. Okay. Okay, this is just one example to show you. So let's say we have some hierarchy. So this is like a new example rather than figures. So we have some aircraft example here. So we have plane. So for the plane, as opposed to helicopter, so we have some lower landing gear, and also lower landing gear is actually simply deferred for the generic plane. And for Airbus, or for other Boeing, or for specifically B747, we actually have a particular implementation for lower landing gear. You can see we have a star here, that means it's deferred. So here we have plus, that means we're making it effective. And so here we have another type of Boeing plane. So here we're saying it is a type of 747, but now we're trying to redefine the lower landing gear with a different implementation, of course. Okay, so now let's see how this example might clarify our understanding for the checking. So here, let's say we have some plane, so we have some Boeing plane. So now we can certainly do this assignment here because B, the base type, is actually more specific, more specialized than plane. Because you can see here, so here, this is more specialized than plane in the hierarchy. Okay? So now, when you say A that take off, so what you really want to check statically is to make sure the base type, which is plane, must have this feature supported. Otherwise, it would be very dangerous if somehow you got a plane which cannot take off, right? Or you have some plane which actually has no lower landing gear. That's even more dangerous, right? Okay, so now the first question to ask is, now we don't actually know exactly what the current shape of A is because we do have some sophisticated coding in between. So now, all we can know is what's the base type of A. So the base type of A is simply plane. And do we actually have a lower landing gear for the plane? Yes, we do. It's over here. It's guaranteed to be there and guaranteed to be supported by any of the subclasses. Okay? And the second question is, if you do have the lower landing gear guaranteed for A, but which version it is going to call for the lower landing gear? It can be for example, here, you can see we might have Airbus, we might have 747, we might have 737, but which version should we call, right? So that really can be decided, not statically, but dynamically. Oh, what did I do? Okay, so that's good. So the second question is about which version should we call? Okay, that's exactly what I said. So here, now, if you don't actually check statically that the base class of A does have a lower landing gear, you'll be too late when you actually take off and then find that you have lower landing gear. Okay, that's basically about the example. So please go over there again and make sure you understand that. So I think a typical question in the exam would be, I might give you some class hierarchy here, and I would say, given this hierarchy here, can we do such and such code in terms of polymorphic assignments, or how would the dynamic binding work with respect to the class hierarchy? Okay, so let's see. Let's go on. Okay, so static typing is to make sure the base class guaranteed is at least one implementation for the feature, like the lower landing gear. And dynamic binding is to make sure among the multiple possible implementations for the lower landing gear is going to choose the right version that corresponds to the current shape. Okay? Okay, it would be really the same. So this is just to go back to the example there that we had. Okay. So one note about the to think about the in terms of generic parameter and also inheritance. So the vertical axis here talks about inheritance, and the horizontal axis here talks about generic parameter. So let's look at the generic parameter here, because that actually occurs before the midterm. So imagine that we actually have a book class. Remember, the book is parameterized by the G parameter. So here we are saying we don't actually care which item we are storing in the book. It can be a string, it can be a date, it can be like a, it can be, we having this dinner this late? Okay, so anyway, so here you have the book class. Let's use the book class as an example. So let me just go back to where we were. Remember, we actually have the class book of G. So this is from the supplier side. And now in the client side, we might have a birthday book. So we can say book of G. And also we might have some home books. And here we have a book of string. Sorry. So it should be dates. You can see now we're just changing from dates into string. But somehow, as soon as you instantiate the G by dates, it's going to replace all the internal workings by dates, as we learned back before the midterm. So that means, in some way, for the book, the operation for get and find are going to work exactly the same, regardless of what kind of items you're storing, because you only care about the way you retrieve the item and the way you store the item into the collection. But what exactly you are storing, it doesn't matter. Okay? So that's about generic parameter. And so there's a horizontal line here. So we say we might have a book of people. We may have a book, well, they're using the list. The list is also a generic collection. So we may have a book of dates, book of string, and book of stack even. So now we're going to the vertical axis, which is the focus of this lecture. So it's really about specializing your current classes. So for example, let's say for the case here, so if you have simply a smartphone, a book of smartphone, then in that case you can store either iPhone into it or Samsung into it. It's really about specialization. So if you decide to actually do a book of smartphone here, then of course anything that's below the hierarchy of the smartphone, which is in this case iPhone and Samsung, they can be stored as well in the book. Okay, that's why I say it's vertical, because it's really about how you actually, so because it's really about the inheritance hierarchy you're talking about. So if you declare your type to be something here, then anything that's in there or below can be stored. So that's why it's vertical. Okay. Okay, that's just another example here for you to go over. Okay, so that's actually back to our example here. So now we're entering another topic that's also very important, which is about the substitutability of the types. I want to just do one example, which is continuation of the smartphone, to actually give you some intuition. Okay, let me just erase the features here. I want to keep the classes the same. You may want to redraw them if you want. Okay, let's say we have smartphone, we have Samsung and iPhone. Let's say we have a feature called get reminders. And then, let's say now we just want to make our reminders, and then it's going to return a list of events. Let's say event is some class you define. So get reminders is going to tell me that, so now I have precondition and postcondition here. So I'm going to use the wrong notation here. Precondition here. Let's say we have some feature here called battery level for the phone. Greater than or equal to 10%, which means if your current battery level is actually lower than 10%, then you simply cannot get this feature executed. Okay. Also, you have the post condition here that result, which is a list of events, that should be equal to all the events today. Okay. Let's say this is the contract, in terms of pre and post conditions for get reminders. Okay, just make sure, I'll just choose some easier to understand example. Pre and post condition. Let's consider some polymorphic assignment here. So we can get some into. So basically what I'm trying to explain is to say somehow, if you want to declare iPhone as a smartphone, there will be some, these two contracts somehow will be inherited to the iPhone class to ensure substitutability. Okay, I'm going to show you, give you some intuition why. To our P1, declare it to be a smartphone. Okay, and then I'll simply say iPhone here. You know, I think maybe P, just P. And then here, I'll just make that a more meaningful name. iPhone and Samsung. Okay, so there's Samsung. Okay, so now, as I said before, if you say, I am expecting a phone, but you're giving me an iPhone, that should be acceptable. Also, later on, if I want to change my phone, now, since I'm only requiring a smartphone, so you may not be able to see that. So I would say, later on, say P is now switched to Samsung. That will also be acceptable because I'm only requiring a smartphone. So now, the fact that I am allowing these two assignments to be both, I'm considering both assignments to be compatible, suggests that somehow iPhone and Samsung are substitutable for each other. Because I'm only requiring some smartphone. That means I can substitute iPhone by a Samsung or vice versa. Or I can substitute iPhone by any other subclasses that I can define under smartphone, like HTC or any other brand, or Nokia. Actually, Nokia is not a smartphone, so that wouldn't count. So, anyway, that's my point. So, let me write it down. The fact that we are able to switch between iPhone and Samsung using polymorphic assignments substitutable for each other. Okay, that's a very important thing for you to understand. Okay, so again, the fact that we can actually do this assignment here, and then to do this assignment later to switch from iPhone to Samsung, that means we're considering iPhone and Samsung as substitutable for each other. Okay, because they are both subclasses under the same superclass. Now the question is, that's what we would think. They should be substitutable for each other. But how do we enforce such substitutability? How do we enforce that? In Java, you cannot. Although in Java you do have the inheritance relationship, exactly like iPhone, but in Java there's no contracts, right? So to enforce the substitutability, you do need contracts, like what we have here. Okay, let me give you some examples. Let's say for iPhone here. So let's say for iPhone, because it's effective, so we must implement the get reminders feature here. You know what, I'm going to write it here, okay? Reminders here, of course, will be the same signature for that. So now, the problem is, what kind of contracts do we have for iPhone? That's the issue, okay? So somehow, let me just give you some principles, okay? So somehow, require less, ensure more. Okay, this is the principle. If you want to see the get reminders feature that's implemented by iPhone is really a proper feature, then you really have to make sure that this feature here requires less and ensures more with respect to the original feature. Okay, I know it's still a little bit abstract here. Let me give you one example. So this will be the correct version. So what will be the wrong version? If you somehow you require more, and you ensure less, right? Okay. This is the principle. Okay. So what can be the wrong version? The wrong would be if you try to require more, and also or you try to ensure less. Okay. I'm actually using the word require and ensure just to let you connect easier, more easily to the precondition and postcondition. Okay? Let's give some bad design so we get reminders from iPhone. So for example here, so let's say, now rather than saying the battery level should be less than, greater than or equal to 10. So now we say it should be greater than or equal to 5. That's not what I meant. Okay, what does this mean? So now, when I'm actually expecting like a smartphone, when I'm trying to get reminders using my smartphone, no matter you see the iPhone or Samsung I'm using, I should expect a feature to be okay to be used. If the battery level should be greater than or equal to 10. But now, this particular implementation actually requires more. It's saying now, what you used to be able to do, you cannot do anymore. You used to be able to get the reminders when the battery level, let's say, is actually 11, let's say. 11 is okay as far as this precondition is concerned. But now, let's say somehow, this version of the iPhone requires that the battery level should be it's like a stronger precondition. So the battery level should be higher than or equal to, larger than or equal to 20. In this case, you're requiring more conditions or more obligations for the clients to satisfy before you can come and get reminders. So that is why this is not good when you're trying to require more. Okay? One example for ensure less. Let's say we used to say you should really get all events happening today. One possible post condition can be result is equal to all events happening after 12 p.m. today. So in some way, it is giving you something, but it certainly is now trying to give you less than what the smartphone can really offer you. Because that means it's going to miss all the events that might actually happen today before 12 p.m. So it's really ensuring less for you. So these are the examples of bad design in terms of the substitutability. So that means if you do have such design for the iPhone, that should not be considered as substitutable for a smartphone. Okay, did you want just some example? And then we will review this example next time, and then I think that for the rest of the lecture will be just a repetition of this. Okay, so before I let you go, do you have any questions about the assignments? No? Okay, so I think I mentioned again, so tomorrow lab, please try to attend if you can. We're going to do one complete example for the ETF, just to help you later on to prepare your lab test.